Right, we're on question number 22. 22, prove that the triangles below are similar and write the proof using complete sentences. Then write the similarity statement and the proportionality statement. Now class, when you get these proofs, you're going to have to go through the three ways that we can prove triangles are similar. We've got AA, SSS, and SAS. Now take a look at this. We don't know two angles of either of these triangles. That means we can't prove by AA. And we can't use SSS because we don't know the third side of both of these triangles. And since they're not right triangles, we can't figure out the third side. That means we're going to have to use SAS. So to use SAS, we've got to find one angle that's congruent. We've got that one. Angle B is congruent to angle D. And then let's verify. We know both of the sides that are around angle B. So angle B is the included angle between the known sides. And then angle D is the included angle. So it looks good. We can try SAS. Now the strategy I taught you in the flip book is take the largest side of one of the triangles and match it up with the largest side of the other. And then we're going to use a square to match up the smaller side to the smaller side. So if you remember this strategy, we're going big to big and small to small. Put a little B here for big to big and small to small. So let's go ahead and set up our ratios. Our big to big ratio is going to be 12 on this triangle divided by 16 on the other. And then for our small to small, we're going to go got to go back to the same triangle where the 12 came from. That's going to be 9, and that's going to be over the small side, which is 12. I'm going to go ahead and just put a little notation here. These are our big sides, and these are our small sides. So let's take a look. Let's do 12 divided by 16. 12 divided by 16 is 0.75. Now if we can get the same value, same scale factor, or the same ratio for 9 over 12, then we can prove they are similar by SAS. Let's try that. 9 divided by 12 equals, bingo, 0.75. Now you got to show me this so I can see your evidence. Here's my evidence. You marked that two angles are congruent. In fact, you should actually write that down. Angle B is congruent to angle D. So look at my evidence. I've got two sides that are proportional or have the same scale factor, and the included angle is congruent. And here's my proof. Since two sides are proportional and the included angle is congruent, the triangles are similar by the SAS theorem. Make sure you fill that blank in with the SAS theorem. All right, let's write our similarity statement. Now, this gets a little more difficult. I know that B and D correspond to each other, so I know in this case my first letter is going to be B and D. The question is, what's my second letter? Now what's good about this is now that you marked your sides, watch this. If I go from B to A, I cross over the circled side length, the bigger one. So let's say that I pick my next letter as A. Now, when I go to my other triangle, I have to make sure the direction I go from D crosses past the circled side length again. That means my next letter has to be E. It can't be F because that crosses through the square side. So it has to be E. That gives me my next letter. And then I'm going to just go grab my final letter, and I forget what it is. Let's take a look. We got BAC. It's going to be DEF. So there is our triangle proportionality. Triangle similarity. And now let's write our proportionality. And that one's easy. Now that we have the triangle similarity statement, we just put BA over DE is equal to AC over EF. And that's equal to BC over DF. Now, if you've done this problem before you watch the video, be aware, I've told you this in class, you can rearrange these letters. You could have put ACB is similar to EFD. You could have put CAB is similar to FED. If you rearrange the letters, you still have to get the corresponding vertices to be in the right place, but that's going to change your proportionality statement. So when I grade this, I'm looking to make sure your triangle similarity, or your similarity statement is correct, and then I'm going to make sure that your proportionality statement matches your similarity statement. All right, let's take a look at number 23. Are these triangles similar or not? Explain how you know in complete sentences. Okay, again, we're going to look at our 3 shortcuts for proving similar triangles. We've got AA, SSS, and SAS. Well, we don't know any angles, so AA is out, but we do know all 3 sides, and that means we are using SSS. Let's go ahead and set up our matched sides. Big side on the first triangle is 12.5. I'm going to circle that. Big side on triangle number 2 is 10. Small side on triangle number 1 is 6. That's going to get the square. And the small side on triangle number 2 is 4. Always big to big, small to small, and then the middle one is the one you don't mark. All right, let's set up our ratios. We're going to check 12.5 divided by, there's our other big one, 10. We're going to check 6 divided by 4. Remember, once I pick this triangle as the top, I got to use that same triangle on the top of every one. And then I'm going to go back to this one. My other ratio is my corresponding side in the middle. That's 10 over 8. Let's check these out. 12.5 divided by 10. That's 1.25. So my first scale factor is 1.25. My next one, 6 divided by 4. 6 divided by 4 equals, it's 1.5. So now we see already, class, we do not have the same scale factor. I don't even have to check this one because I already know we do not have proportional sides. So my explanation here is, here's my evidence. I've got 2 numbers that don't equal each other for my scale factors. So since the corresponding sides are not proportional, we cannot prove similar by the SSS theorem. Make sure you put that theorem in the blank. All right, we got one more, number 24. Are these triangles similar or not? Explain how you know in complete sentences. Well, we got our 3 possibilities for triangle similarity, AA, SSS, SAS, and nicely they've given us 2 angle measures, so we can try to use AA. All right, well, I'm looking at the angles. I see that angle G and angle R are congruent, but F and T are not. And your first response is going to be, oh, therefore I know they're not similar, but don't jump to conclusions. We have to check the third angle. So we know that the measure of angle E is going to be equal to 180 minus 38 minus 47. I'm going to take 180 and subtract the 2 known angles. When I do that math, I'm going to get 95. So this angle measure is 95. And that does not match 93. Now, if you want to make absolutely positively sure, let's find the measure of angle S also. The measure of angle S is equal to 180 minus 38 minus 93. Let's see what that is. I'm going to work that one out. So I got, hold on a sec here. Let me get this moved where I want it to be. I've got 180 minus 38 minus 93 equals, and that is 49 degrees. And now you can see that we absolutely do not have a second angle that is congruent. So here's my evidence. I labeled my triangles. Don't forget to label your angles so I can see it on the test. And now you can write here, since 2 angles are not congruent, we cannot prove by the AA theorem. Make sure you plug in the AA theorem here. Last question for this video. What are the 6 properties of dilation? Class, you're going to need to know all 6 of these. These are in your flipbook under dilation properties, and here are the properties. Every dilation has a center of dilation and a scale factor, and you should say actually and, has a COD and scale factor. Corresponding angles are congruent. We just saw that with AA. Corresponding sides are proportional. That means they have the same scale factor. Corresponding sides are parallel. Remember we discussed that in class about parallel sides when you use a dilation. The distance from the COD to the corresponding vertices is proportional. I should actually add here corresponding. Let's abbreviate that. Corresponding vertices. I'll put a P there so I match up with my other abbreviation. Distance from COD to corresponding vertices is proportional, has the same scale factor as the corresponding sides, and then the orientation of the image is the same as the pre-image. It doesn't rotate or reflect when you dilate an object. It ends up being turned the exact same way as the original pre-image. So there are the 6 properties of a dilation. Make sure you know these. You will have a question about this on the test. And that's the end of the review sheets.